This is a very typical time series question. This is the sort of thing you can expect to have to do on the exam. It's a question that deals with seasonal data. I can spot that, well, partially by looking at what I see here in the questions themselves. Provide the seasonal indices, provide the de-seasonalized values. These are words that they would only use when you have seasonal data. However, seasonal data can be identified just by looking at the data itself. Seasonal data means that not only do you have a time series, so time series is where you've got progressive or increasing time periods, so I go from 2010 to 2011, 2012, and 2013, and so on. So I've got my increasing time periods. That makes it a time series, but for it to be seasonal data, tells me that I have to have within each one of my larger time periods, I have to have a repeating pattern of smaller time periods. So winter, spring, summer, fall, that happens in the first year, and then it gets repeated in the second year, it gets repeated in the third, and it gets repeated in the fourth year. So seasonal data is when you not only have time, a series of observations over time, but you also have to have repeating groups of time periods. So winter, spring, summer, fall, they could be called winter, spring, summer, fall like they are here. They could be called quarters 1, 2, 3, 4. It could be a very simple question where for the first day you take an observation, let's say that for day 1 you take an observation in the morning, the afternoon, and the evening. And then in day 2, you take an observation in the morning, the afternoon, and the evening. Day 3, you take observations in the morning, the afternoon, and the evening. I do have a time series because I'm progressing from one day to the next to the next. However, it's also seasonal data here. Even though these are not normally considered to be seasons, these times of day, we do have a repeating set of time periods. That's what makes this also a seasonal data setup. So that's exactly what we've got in our question. And so we're going to be able to do things like find the seasonal index values or provide the deseasonalized values. Incidentally, these two first questions here, these are the most, well, let me put it this way. If you have seasonal data, you can depend on being asked for your seasonal index values, and I would say 100% of the time. And as far as giving the deseasonalized values go, that'll be in the majority of questions. So this progression of part A and part B is always something you should be prepared to do on an exam. Seasonal index values and deseasonalized values. If you can't do that, then you really you're not prepared for chapter 6, or you're not prepared for seasonal data. So we have to make sure that we're going to get these taken care of, and then we can get into a forecasting question. And then after that, there's a series of other follow-up questions here that are going to be a little bit easier to get through. These are very quick follow-up questions. The first two, though, the seasonal index values and the deseasonalized values, there's quite a bit of math that's involved. To keep track of it, what I've done is I've taken my, my data table here, and I've changed the format a little bit. It's still all the same data. Here's all of my observations in the Y column. So these 16 values here, these are the 16 values that were in that original table. I've still kept track of year 2010, 2011, 2012, and 2013. I put winter, spring, summer, fall here, but the idea is that winter, spring, summer, and fall, that gets repeated again and again, and so on. And I've also labeled these as quarter 1, 2, 3, and 4, just to make things a little bit easier to refer to as I'm going through and doing the mathematics. This is not really necessary. You don't have to call them quarters. You could just call them W, SP, SU, and F. Makes no difference. But one thing that is going to be necessary, well, actually a couple of things, I'm going to need to create a table, and I'm going to need to create a table as large as this, because again, there is quite a bit of math for us to go through, and we want to be able to keep track of it. There's going to be a lot of detailed calculations, so having a proper table set up is really important. I have noticed on past exams from time to time, they'll give you a blank table that helps to keep your structure together, but very often it is completely blank. They don't tell you what the columns are that you're going to be filling in, so you're going to need to understand as we go through step by step how to repeat this yourself. So creating a table is the first thing that's going to be necessary. Beyond that, make sure when you first put down your data, you leave a little bit of space here, like I've got. Now, I left this space before my data so that I could put in what's called time t. Now, Q1 to Q4, that keeps track of my repeating pattern, but time t is supposed to keep track of just how many observations I've made so far. So, for example, this is my first time period, my second, my third, and my fourth. But then I'm not going to repeat. I'm going to keep progressing. So there's my 5th, 6th, 7th, 8th, and so on. So with time period t, you do not repeat. You just count from the very beginning to the very end. This time period t column is not going to be all that important for now. It'll be later on when we're doing some forecasting. So you're going to see this time period t come up when we get to where is it? When we get down here to part C, where we're actually going to be asked to do a forecast. That's where little t becomes a big issue. So we've got that there for now. We don't need it to go any further for parts A and B, so it's tucked out of the way. What I do need, though, is I need to start off with my very first column, which is going to be my moving average. And the moving average, which you can call MA for short, is similar to what was taught at the beginning of this chapter, but there's a little bit of a difference between how you deal with moving averages for seasonal data and non-seasonal data. So here I've got my seasonal data, and so a moving average is going to work like this. Let me finish my column a little bit, and then I'll get into a proper explanation. Okay, now, with a moving average, when you first learn about moving averages at the beginning of the chapter, you learn about what's called an n-period moving average. Because a moving average is this sort of an idea here. Let me just give some sort of a made-up example of numbers. So I've got the number 3, 5, 10, 12, 18, and so on. If I wanted a moving average, that means that I'm going to take an average of a set of these numbers, but I need to know how many at a time. So that's why it's called n-period. How many periods do I average together at one time? If I was doing a 2-period moving average, that would mean that I'd take the average of these two, and so then I would put my first average here, and then I'd take an average of the next two, but not completely the next two. There's going to be some overlap. I'm basically just bumping myself up to starting at the next number. And so that's going to get put down here. And then I progress one more and I grab the next two. So that would be my 2-period moving averages. If, however, I was asked to do, so this would be 2-period. If I was asked to do, let's say, 3-period moving averages, 3, 5, 10, here's my original data again. A 3-period moving average would mean that I take an average of the first 3 numbers and I put it down here. That would be my first group, or my first group average. And then I take another average of these 3 numbers. That would be the second one, and so on. So I'd keep going that way. So it completely changes what your results are going to be. Like the average here, my first average, that's the average of 3 and 5. The average of 3 and 5, that is a 4. What about over here? My first average is the average of 3, 5, and 10. That's 18 divided by 3, so that's going to be 6 as a result. So your result completely depends on how many periods you're going to be averaging at one time. So you need to know how many periods. Well, they're not going to tell you that when you're dealing with seasonal data. But the idea is that if you have a repeating set of 4 time periods, winter, spring, summer, fall, and then again winter, spring, summer, fall, then you use that group of 4 as your n. So I'm going to take a 4-period moving average because there are 4 seasons repeating here. Not every question is going to have 4 repeating seasons. The example that I gave earlier on, where there was morning, afternoon, evening, and then morning, afternoon, evening, and so on, here I would want my moving average to take 3 at a time, and then these 3, and then these 3, and so on, because there are 1, 2, and 3 in my set. So what this tells me is that I'm going to have to take the average of my first 4 numbers, so 2010, 2060, 2010, 2060, 480, and 250. I have to take the average of these 4. And here's another thing that's going to be very, very important about seasonal data. The first thing about moving averages that I said was important is that your number of periods is the number of seasons. The next thing is going to be, we don't put our value below. Like, for example, if I have 1, 2, 3 of these in my first moving average, I then put the answer in the future. I put it in the next time period. Here I had these 2, but I put my answer, the average of these 2, in the future. So that's what we would do when we have non-seasonal data. This is not what you do when you have seasonal data. When you have seasonal data, you do not put your answer down here in the future. Instead, you have to put your answer exactly in the center of the values that got used as the moving average. So here's my center right here. Now that's going to be kind of awkward because there's a line right in the center. So what I'm going to do is I'm going to change my table to get rid of these lines. Let me take a second and do that, and then I'll show you how it should be set up properly. Okay, so I've erased all the lines in this column, and only in this column. I really only have to adjust things for this moving average column. What I'm going to do is, because I need to have my average of these first 4 numbers, which incidentally is 300, so if you take the average of 210, 260, 480, and 250, if I want to put that right in the middle, that answer of 300, it was going to be right on top of a line, and I don't want it to look like that, so I don't want it to be difficult to read. So I put it right in the middle here. Now, to make this a little bit easier to keep track of, what I'm going to do is I'm just going to put my lines down a half step everywhere, like this. And I'm going to keep doing that all the way down. So let me take a second and get that done. Okay, so now I've done that. So, like I said, the average, my first average, which is the average of the first 4 values, comes out to be 300. But considering that this is a moving average, what that implies is that I now have to get my second average, which is going to be the average of the next 4 numbers. So 260 plus 480 plus 250 plus 215. I divide that by 4 to get my average, and the result comes out to be 301.25. Now, you might be asked to take this to 4 decimal places. I could, but there's nothing after this. This is 2500. So I'm only going to write as many decimals as are necessary, at least for this column. I'll be I don't know. It's a lot to go to 4 decimal places just for this example. It could end up crowding us right out of our table. Maybe I'll go with 3 at most for the rest of this example. You should be prepared, though, on your exam to check and see how many decimal places they want you to carry, because it can change your answer to a significant degree if you are rounding off too early. Okay, so I've got my first and my second value here, but I can keep stepping down one at a time. So for example, now I'm no longer going to include the 260, I'm going to move down and start with the 480, and I'll include 4 values, always 4 at a time. So 480, 250, 215, 275. That'll give me my third moving average. So my third moving average is 305.000. So I'm just going to leave that out. And then the next moving average, if I keep going down this way, is going to be 307.5, and so on. So hopefully you get the idea here. Let me do the next one manually. So I'm going to, let's do this in a different color so you can see where I'm starting. I'm going to go starting from 215, and now I'm going to include down to 255. So these numbers are 215 plus 275 plus 490 plus 255. And then to do a proper average, I have to, once I've done adding them together, I have to divide by 4 because there's 4 values. And this is going to give me an answer of 308.75. So I put that in here, 308.75. Okay, so I'm going to keep filling these out. I've calculated them in advance, so let me do that. Okay, so I'm almost done. I just want to show you what the last thing is that I did. I took the average of 265, 220, 290, and 525, and these average out to give me 325. Now you'll notice that there's only one number down here that I haven't used yet, so I've got one more opportunity to do a moving average. So again, let's do this at a slightly different color. There's my last group of 4. When I take the average of 220, 290, 525, and 270, I get 326. 326.25. Now there's nothing else down here for me, so I have to stop. There's not going to be any value down here, and then in this half row down here there's not going to be any value. You'll notice if I had started cutting these in half at the very top, then there would have been a half step and a full blank. So 1.5 blanks at the top, 1.5 blanks at the bottom. You're always going to get this pattern. Whatever you couldn't do at the top, you're also going to be leaving blank at the bottom. This is there's nothing missing here. There's no missing information. It just has to do with the fact that we're grabbing groups of values and taking an average, which sort of points them in like a pyramid. So there's going to be some missing space here. So there's no problem with that. Now, the next thing that I have to do is I have to make a correction because we had an even number of seasons. For example, quarter 1, 2, 3, and 4, there's 4 seasons. That's an even number. When you have an even number, like 4, and you're taking averages which end up in the middle, like we've got here, that puts the 300 not really in line with quarter 2 or quarter 3. Instead, the 300 is sort of sitting in between 2 quarters. Now, that's a problem, or it will become a problem later on, because what you'll notice is that as we go through the mathematics here, what we're going to be working towards is describing the typical behavior of each quarter. Let me give an example of this to put it into context. Let's say that, let's clean this up a little bit. Let's say that you have a retail business where you've got quarter 1, quarter 2, quarter 3, and quarter 4. Let's say that this is, I don't know, let's say you sell chocolates. Now, chocolates or candies or something like that. Now, quarter 4, that's around the end of the year, that's the holiday season, and so in quarter 4, you're going to find that you get more sales than normal. Maybe you're going to end up having sales that are 200% what you would expect. Your sales jump by quite a bit during the winter or the Christmas season. But now, right after that, in the next year, you're going to be at quarter 1. And so people are paying off their credit card bills. You're not going to have people with as much money to spend or reason to spend money. So maybe you only make half of the sales you would expect. And then maybe in quarter 2, again in the spring, people start to buy stuff, and so maybe you have a little bit more sales than normal, and maybe during the summer, sales are just very average, very typical. They're neither up nor down. These are what are called seasonal index values. This indicates that in the winter, you have increased sales. In the spring, you have decreased sales. These are seasonal effects. So actually, this is more like, yeah, okay, this would be the fall and this would be the summer. I guess I had that wrong before. But anyways, the idea is each quarter can have its own effect on your sales. Or if you're looking at something like the Grand Canyon, maybe the different seasons have an effect. Maybe it's very hot where the Grand Canyon is. I've never been, so I'm not 100% sure what the temperatures are like. But let's say that it's very hot, and so maybe in the summer you get decreased, or actually no. You can see here, look at our first summer value. The number went from 210 to 260, suddenly it's 480. What could account for that? Well, actually, there's a really simple reason. Think about it this way. Families probably like to go visit the Grand Canyon, and kids are in school for most of the year except for the summer. So you're suddenly going to have a seasonal increase in visitors during the summer. Does that happen every year? Well, let's look at the second year, 2011. We've got 215,000 people, 275,000, and then suddenly in the summer we have 490,000. So that's a seasonal effect. So everything we're going to be doing in this question is really going to be about trying to keep track of what the effects are of different seasons. Obviously, the summer has an effect on our data. Maybe the other seasons do as well. You can see here in the winter that the numbers are typically small. 210, here's another winter, 215, that's the smallest all year. It's even smaller than the fall right before. So in the winter, maybe it's not such a popular destination. Now, back to our 300. 300 is not telling me any information about quarter 2 because it's not on the quarter 2 row. It's also not telling me about quarter 3. It's not on that row. I need to line these up properly. They need to be shifted towards lining up with the quarters. So this is an issue that occurs whenever you have even numbers of seasons. By contrast, if I had an odd number of seasons, have a look at where the average would go that comes from morning, afternoon, and evening. The average would sit right here. Sorry, this is horribly messy. Let's put this down here. Let's say I've got morning, afternoon, and evening, and I've got a number, and a number. Let's say I've got my different observations. If I wanted to take an average of these three numbers and put it in the middle, it would end up being right here. Here would be my average. My moving average would be sitting right in line with afternoon. And then my next average would be right here. It would be centered on this evening. There would be my next average. If I have an odd number, like morning, evening, or morning, afternoon, evening, there's 3 of them, and so on, 3, you don't end up with this problem where you are shifted out of sync with your different seasons. So this is something that occurs when you have an even number. Anyway, so how do we fix this? Well, we create another column that is called CMA. That is my centered moving average. And the way you center things is very simply just to take the average of 2 at a time, and always just 2 at a time. So I'm going to take the average of 300 and 301.25. That average comes out to be 300.625. I then take my next average of, like I said, always 2 at a time. Never anything different. So I'm going to take the average of these 2. And so that gives me the average of 301.25 and 305. Average those out, and you'll get 303.125. My next average is going to be the average of 305 and 307.5. And so when you do that, it comes out to be 306.25, and so on. So I'm going to fill all this out, but before I do that, let me point out that this first number, this 300.625, if you run across, this happens in quarter 3. This reading here belongs to a summer. The 303, if you carry across, this belongs to quarter 4. This is a fall reading. This is going to help us with our mathematics that will decide what is the effect of the summer, what is the effect of the fall, how do summer and fall and winter and so on, how do they affect the number of visitors? So that's really what we needed here. And so we've corrected so that our averages are sitting right in on rows that we know what the season is for that row. So let me fill out the rest of these and then we'll move on. Okay, so now I've got all of my centered moving averages. Once again, you'll notice that there's an empty cell here. There's an empty box. There's a second empty box. So 2 of them at the bottom, but also 2 at the top. So this is our expected behavior. So now that we've got all these, what is it that we do with these? Well, the next column is what's called Seasonal Irregular. And the Seasonal Irregular column is fairly simple to work out. What we're going to do with it is we're going to take our actual reading. So let's say, look at this 480 here. We're going to take that 480 and we're going to compare it to the centered moving average. Remember, I said we were basically focused on measuring what sort of an effect each season has. Well, these centered moving averages, what they're doing is they're giving us an expected value. So for example, in this first summer, we expect to have about 300,000 visitors. The fall that comes after that, we expect about 303,000 visitors. In the winter that follows, we expect about 306,000. You can see here that there's a progression. We're going from 300 to 303, 306, 308, and so on. Now, this is just what's expected according to the mathematics. But what is the actual reality? Well, the summer, as we've seen before, leads to dramatically increased numbers of visitors. We don't get what we normally would just expect if there was a gradual increase. Instead, the summer has a big effect. We have 480,000 instead of the expected 300,625. So what are we supposed to do with this? Well, we want to measure how close is the actual value to the expected value. And we're not going to do any addition or subtraction. We're not going to see what the difference is. Instead, we're going to do this as like a percentage. So this is how it works out. Your seasonal irregular is going to simply be your actual y value divided by your centered moving average. So let's see what we would get there. If I take 480 and I divide 300.625, so 480 divided by 300.625, let's do that over here. .625. What does this give me? It gives me 1.597. Now, what does this number mean? Well, 1.5, if it was simply just 1.5, that would be 1.5. That means that 480 is about 1.5 times the size of 300. Or it's not exactly 1.5, it's even more than that. It's almost 1.6 times the size. So this tells me how much bigger my actual value is compared with my expected value. So it's almost 60% bigger than what we normally would have expected. That's what we're going to put in for our seasonal irregular. We're just going to put in the results of those calculations. So this is 1.597. The next one I'm going to do has to line up. It's going to be my 250 divided by my 303.125. So you can see that 250 is not as big as 303. We didn't get as many people as we would have expected. So look at what the result is. When you take 250 and you divide by 303.125, it comes out to be 0.825. What does this mean? Well, think about it again as a percentage. This is 82%, almost 83%. That means we didn't get 100% of what we expected. We only got 82% or 82.5% of what we expected. The 250 is not as big as the expected 303. In the previous part, we got more than what we expected. We expected 300, we got 480. So that's 159% or almost 160% of what we expected. So again, I'm just going to fill all these out, and then we'll come back and talk about the next step. Okay, so I've got all of my values filled out. Now, of course, I have to leave blanks in the same places because we can only do this math. We can only find the seasonal irregular when we have both the actual value and the expected value. So only in rows where you have both of those will we get the chance to fill in our seasonal irregular values. Okay, so what are we going to do with these? Well, once again, remember the whole point was we were trying to measure the effects of each of these different seasons. We want to know, does a season lead to an increase or decrease in the numbers of visitors? We know already that the summer always sees an increase. We know that the other seasons, like the winter, usually the numbers in the winter are small. But we want to know just how much smaller, or in the summer, just how much bigger. Well, have a look at, let's just focus on the summers. Here's a summer here that is basically 160%. Let's go to the next summer. This is 1.585. That's, again, about 160% of what's expected. Here's 1.589. That's almost 160%. So you can see that there is that, there's that basic almost 160%. It's never the same number, but it's always kind of close to the same number. So what we're going to do is we're going to work out what is that number. What is the average effect of the summer? We've got 3 summer effects. We're going to work out the average summer effect. So let's keep those up there, and I'm going to create a bit of space again. Okay, so my different values were as follows. This is for, let's start off, I know that we're starting off with the summer, which is Q3. My different values are 1.597, that's the first one that I see, and then the next one was 1.585, that was the next one that I put a dot next to, and then 1.589, that was the third summer season. Now, we do actually have 4 summers in our original data, but we only were able to get 3 seasonal irregulars for the summers. So that's fine. That's all that we can get. So we're going to take the average of these 3. And when you average these 3 out, let me see what that works out to. When you take the average of those 3, you get 1.5904. This is what's called the seasonal index. And this is the seasonal index for Q3. We can also find the seasonal index for Q4. We can find the seasonal index for Q1 and for Q2. I know that these are out of order, but it doesn't really make any difference how we do this. So as long as we keep every Q4 reading along the same line, every Q1 reading has to go here, every Q2 reading has to go there. So let's look at our Q4 readings. Those are going to be the ones right after, each of our summer ones. So here, here, and here. So 0.825 is the first one. This goes with, you'll see this carries across to be Q4. This one is a Q4. This one is a Q4. So 0.825 is my first one. The next one is 0.822. The next one is 0.831. Okay, when you take the average of these 3, it comes out to be, this is for Q4, this comes out to be 0.8257. In Q1, I've got which readings? Here's Q1, right here, and then my next Q1 is right here, and my next Q1 is right here. So let's take these readings, the first one being the 0.702. The next one is 0.696. The next one is 0.682. The average of these 3 is 0.6935. Okay, And then finally we need quarter 2. So my quarter 2 readings are there. That's a quarter 2 reading. So with the line underneath, that's a quarter 2 reading, and that's a quarter 2 reading. 0.892, 0.892, and 0.891. So 0.892, 0.892, and 0.891. When you take the average of these three, it's 0.8916. So these are my different seasonal index values, and that's excuse me, that's what they asked for in Part A. So it would seem like we're done. We've collected seasonal index values. There is, however, a check that you have to perform at this step, and you might lose a lot of marks if you don't perform this check. It's a simple check. It just means that we have to get the total. The total of these, if you add up 1.5904 and then add 0.8257 and so on, add all 4 of these numbers, it will come out to be 4.001. So what do we do with this total? What is this check for? Well, this is supposed to be the number of seasons. But you can see that it's a little bit more. This is not 4.000. This is just a little bit more. Now, this is not much more. In a lot of cases, you will get more of a difference. However, I want to show you how to correct this. We can make this turn into 4 exactly. So when you perform this check, you're supposed to be checking to see, does it turn out to be equals to the number of seasons? If there's any difference, regardless of whether it's big or small, if you find a difference on your exam, what you should do is a correction. And this is what's going to be called the, let me do this in white. This is the, oh, actually, no, it's called the scaled seasonal index. So if they ask for the seasonal index, that's not really what they want. These are the seasonal index values. What they really want are the scaled seasonal indexes. When we add up our scaled seasonal indexes, they will come out to be 4.000. So how do we get these values? How do we fill these numbers in? Well, you have to multiply each one of your results by the same amount. We're going to multiply them by the number of seasons that we should have had over the total that we did get. So you have to multiply them by this. So this is going to be multiplied by 4 divided by 4.001 and so on. If you work this number out, 4 divided by 4.001, it comes out to be, this is it in fraction form, but if I put it in decimal form, it's 0.999721. So if I multiply each one of my previous seasonal index values by 0.999721, these will be the results. I'm going to get 0.6933. Oops, nope. This first one is going to be 1.5899. The next one is going to be 0.8255. When I multiply 0.6935 by 0.99721, it's going to give me the result 0.6933. And when I finally multiply my last seasonal index by this correction factor, it's going to be 0.8913. When you add these guys up, you will get 4.000. These are what are called the scaled seasonal index values. If they don't ask you for these by name, they still mean that they want them to be scaled. They want you to check and see, did it add up properly? Because if there's a difference, you have to apply this correction. Once you apply that correction, you're going to get your scaled seasonal index values, and that will check out by giving you the exact number of seasons. Now, if it doesn't give you the exact number of seasons, it will definitely be closer than what you saw here. So what if this was, let me give you an easier example. What if this was 4.023, and then this one, after you corrected it, was 4.001? Normally, you would have to correct again. But on the exam, they're only going to expect you to correct it once. So you only have to run through this correction once. So even if this didn't come out to be exactly 4, I would stop there. In our case, it was already extremely close, which led us to being able to get exactly there. Okay, so that's it for part A. My official answer for part A would be this. I would say this would be how I would word it. I would say that my scaled seasonal indices are quarter 1, quarter 2, quarter 3, and quarter 4, and these are just the numbers that came from here. So they are, for quarter 1, it's 0.6933. For quarter 2, it's 0.8913. For quarter 3, it's 1.5899, and for quarter 4, it is 0.8255. So that would be my final answer. But of course, I would have to show them all of these calculations. And probably the hardest thing you're going to have to do is keep track of what to do as you move from one column in this table to the next. So a bit of practice is really the best thing there.